Zoom is always not working.
Yeah.
It's Zoom.
Yeah, the Zoom.
Yeah.
Did everybody already go home? I know Dominic.
A lot of people left. Yeah, but we not. Let's finish our section.
Okay, thank
Yeah.
you. Thank you.
Can you share? Can you share?
I can share, yes. Hi, everyone. I know it's probably 2 long days, so I'll keep it short, try to keep it short on, and let's keep it interactive, right? So you all know a lot of the platform. I mean, originally I planned to present the H2O.ai Cloud overview. I'm sure you got a bunch of it from Jesse over there and the team. So I'll try to keep it short, jump directly to the product and show the demos and the new stuff that we've been working on. And if there's anything of interest that you want me to focus on, we can do that as well. Okay. Are you able to see my screen?
Yep.
All right, let me go to the full screen. So, oops, to the wrong slide. Okay. All right. So, you all know this, but very quickly, if anyone in the room doesn't know about H2O, we've been in business for about 10 years now. We have a fairly long, lengthy history with Aetna and also with CVS, but also overall we've been working with banks, insurance companies, healthcare companies, manufacturing companies across the globe, some of the biggest Fortune 500 companies in the world. We have a fairly large open source community as well, which we are extremely proud about. That's where the company originally started with. So a big meetup community, strong data science community, practitioners all over the world coming in. We are venture backed, and the interesting thing about us is we are actually backed by most of our customers rather than traditional venture backed investors, right? So folks like Commonwealth Bank of Australia, Goldman Sachs, Ping An Ventures, Wells Fargo, Capital One, they're all customers and partners and investors in our company. So we are truly, we have this mission to democratize AI. We want to make sure that we create a standalone, strong, independent AI company that is focused on delivering customer value. Okay. And as you can imagine, there's a lot of use cases we do across the platform, right? Financial services, healthcare, life sciences, of course, telecom, marketing, retail, manufacturing. A bunch of those are not in the slides, right? So we do a lot of use cases. We are a general purpose AI machine learning platform that can serve all kinds of use cases, from structured data problems to unstructured data problems, deep learning problems. And we have a full-fledged stack, and we'll talk about the cloud itself. And that's the topic of the day: is what is the AI cloud and why do you need an AI cloud, right? This is just some small listing of our large customers, some of our key partners. Extremely exciting. And we work very closely with some of you over the years, and I thank you all for your trust in us as a company, as a partner, and we continue to expand that and keep investing on that. And it's not just about doing the customers in the community, right? It's about in the end, we are a business, and we need to deliver value. And we've been successful in delivering some phenomenal value for some of our customers. Again, often this is very hard to parse out, even for companies internally, right? Internal data science projects, often the ROI is mysteriously not known fully, but we try to figure out, and we've been able to do, from like the largest ones are like, things where we can save almost billions of dollars in savings in fraud use cases, to bond trading, which can mean hundreds of millions of dollars. Insurance underwriting can be in tens of millions of dollars. A lot of value has been generated across different customers, different verticals, and we are extremely proud of that, right? So it's that's where the rubber hits the road. This is so often AI projects seem to go nowhere, but we have been very successful in delivering value to our customers. And like Michael was saying, keys to understand what use cases, what business outcomes are we focused on, and then start with that. So let's come to AI cloud. This is the topic of the day, right? So for me, at least, is like you've probably heard from a lot of our other vendor competitors in the space, from who talk about their own platforms. But generally, AI is important. Everyone is aware of that. Most execs say that. There is reports from Gartner, from Accenture, saying that more than 3/4 of executives acknowledge that AI is important, but they also know that AI is not just important, it's critical for their business outcomes. They will lose their competitive advantage if they don't use machine learning and AI in their workflows. But the big challenges are the same amount of them, or maybe an equal amount, also admit that they know how to pilot, but they're not able to scale AI across the business. This is a big challenge because this is where it goes from being from a center of excellence or a pilot project to becoming an enterprise-wide initiative, and it runs into all kinds of challenges. Some of which I think Michael had, alluded to earlier, but a lot of it is around related to change management. How do you change the organization's working style, how their philosophy, and ensure that they can get advantage of AI? And that's what we want to talk about. So we created this AI maturity framework as a company, and we've been sort of working using this as a rubric to understand where are our customers, what part of the stage they are in, and a journey perspective, right? And we find that a lot of our customers, they come in, they are very good, and that ideation or pilot phase, center of excellence, they have a lot of some initial use cases, some value, some strong insights, but then they don't scale it. It's very difficult to go from like stage 2 to stage 3. And at a high level, I mean, this is where it's basically you are in this. We call them like the proof of concept or pilot stage. And the reason is there is lack of like foundational architecture, there are data capabilities, there is lack of support across the organization, and not due to not due to a need perspective or want perspective. Everyone wants it, but they don't know. They have so many legacy systems that are set in place or fixed ways of working that are difficult to change. And that's a big part of what we sort of set out to solve is obviously we are a technology company, so we approach it from a technology perspective, but we do admit and understand that this is a people problem as well. So working with our customers, working with large organizations to make those changes, how do you transform an organization from within to be able to go in not just from two pilots of AI projects, but actually get to scalable enterprise grade projects? That's kind of our goal. So some of you might see and seen this. It's maybe not unfamiliar, right? Like you typically start off, how do you work on a project? You take a data scientist gets assigned a project or a use case. They start working on it. They create a great notebook. They will spend weeks on it, days on it, weeks on it. Great notebook. They present it in a conference like this. Maybe they write a paper about it, and then they try to see how they can put it in production. That's where some of the challenges start hitting you, right? What does production mean? It changes depending on use cases, depending on what the end outcome is. Making sure that there is a data available during production time. Can it be scored in real time? Does it need changes on their end user applications? Does other systems have to change? All these questions start coming up. But even when let's say someone gets to those steps, they get to a stage where they're able to create predictions and put it in the hands of a business user. The business user may not understand what those predictions mean. They don't know why the model was built in the first place. What does it do? And and they more importantly don't have trust. They don't know how they can trust those predictions. So what it ends up happening is it becomes a glorified science project, and no value is added. And unfortunately, we've seen this time and again. We've seen this way too many times in our customers. Months spent on these use cases, and with no great outcome. And that's a shame because these are smart people. We are all life is short. Like current economic climates, for example, dictate that we need to be really good about the use of our time and energy and resources. So how do we make sure that some of these things, these projects don't end up in like a no man's land, right? So what we've seen is if you transform this a little bit, right? Again, pardon us, because as a technology company, we have a technology lens for this. But what I find is if we set it out in a way that where instead of weeks or months spent on building models, using no code or optimal tools to bring models much quickly, still, and also with the ability to have explanations built in, and having a loop where business owners and business users and the final outcome owners are in the loop from the beginning. So you start with the change management. So start with the business outcome, work towards solving that, having a buy-in from those business owners right from the beginning. And then the technology aspect comes in, making sure that you don't have to recode stuff. Your models are built quickly. They're explainable. They are safe to use, and you have a very easy way to put it to production. And the final stage is important too. How do business users then integrate with it, right? So the final outcome needs to be in a business user-friendly dashboard, application, user interface that allows them to do decisioning on the model, not just get a prediction, not just get a probability, but get actually insights, and then those insights can be used to make some decisions. This loop needs to happen, and this happens. We've seen some of our customers implement this and get to a stage where they can go through this entire cycle in less than 2 weeks. And that is phenomenal because they can have models put into production, applicant insights driven decisions being made, and change happening in a matter of weeks. And we believe this is possible for every enterprise. It'll take work, but we think it's doable. Another piece I want to mention, this becomes extremely critical, is having this enterprise-wide system of record. This has also become more and more important as AI and machine learning have become more mainstream. The biggest challenge for everyone is what is the risk from AI? How do I de-risk my AI? Right. So governance is critical, and monitoring across the organization is critical. So when AI systems become the key ones driving innovation, driving change in the organization, you need to know what data and data went into model, who approved the model, is the model safe, did the model follow best practices, are there any biases, are there any bad data that going the model, how do I ensure that this model is the best model, can I test it constantly against challengers or champions or do A/B testing, and when in production can I know when the model is going bad, can I check for those. This also extends to downstream stuff, right? So often when vendors like us, we like talk about MLOps and all those pieces, but really it comes down to how these models could be running anywhere. They could be running on the edge. They could be running on a low power device somewhere. They could be used by a user in the mobile application. So you still need to follow all these governance systems, right? So having an enterprise-wide system of record becomes critical, all the way from features to data to models. All right. So what is the H2O.ai cloud, right? So this is the culmination of all the challenges we've seen, and we've seen that enterprise need all these pieces. So we started out to build this ourselves, and what you get essentially is a cloud that solves for all those pieces. Starts with a way to make. When they say make is our language for creating AI, creating models, creating applications, creating features, whatever it be. How do you build all those things, right? And we have a whole bunch of AI engines now on the platform. So a lot of you might be familiar with H2O3, which is our big data machine learning engine. Very popular, great for tabular data and time series data. You can do unsupervised, supervised learning. Then you have Travelers AI, which is our AutoML engine. That's also very popular, very widely used. But what we've done is we have extended that to include things like Hydrogen Torch, which brings in no-code deep learning for unstructured data problems. So all your unstructured text, computer vision, audio, video use cases can all now be handled again with the no-code deep learning framework. So make it really easy for anyone to start using this, solving these problems. We have something called as Document AI, which is an intelligent document processing engine. So it brings all your unstructured data in the form of contracts, the forms, images, like any document that might be there, faxes, bring them all in, and you can read from those, OCR those, and have intelligent character recognition and then modeling to track and get information off of it. And finally, we have the low-code app development framework, H2O Wave. This allows us to build rapidly prototype applications and put them in production. We then have the entire operational infrastructure as well. So while we make all these amazing things, how do you operationalize this? So there's three key pieces. First comes the feature store. Feature store becomes a critical piece of this puzzle to ensure that the features you build as an organization are available for everyone, for reusability, for sharing, collaboration, and having full governance baked into it. Right. So this is a big part of this is available as part of the platform. We have MLOps, which is related to model hosting, monitoring, and deployment. And all of this can be run on a flexible architecture with our hybrid cloud and managed cloud. So whether you want it hosted by us or hosted in your environment, whole stack is taken care of for you. And then finally, we have the innovation piece of it. This is where you use all of those components to build innovative applications. So we have an app store full of amazing applications that users can take, reuse, and start using it, or they can build their own and have that. So the goal is to have every enterprise should have their own internal app store full of intelligent applications that are solving all kinds of enterprise problems. And that's what we enable with the AI Cloud. So the AI Cloud basically allows you to enable all of those pieces. Put in another way, this is a little bit of like a detailed diagram of the same thing, right? What do you get out of this, right? So the AI Cloud, of course, we talked about all the capabilities, but under the hood, it does a lot of things for you. It takes care of all your authentication, ensure that your data is safely, only people who have access to data can use it. Sharing and collaboration are again done through the platform, so you don't have to worry about role-based access or unauthorized access of your data. It works with your enterprise identification mechanisms. runs on Kubernetes so that it can be scaled very easily on any cloud or on-prem. We have also an option to deploy it for you, manage for you. And with all of these pieces, you now get a full set of SDK, like different user interfaces. You have GUIs for all these, but we have rich Python API for all of these components as well. So you can interact with the entire platform through code and automate this whole thing, right? So that's important. We also have an IDE for notebooks, so you can come in and build your own models. And for the first time in H2O, we've also opened this up for third parties. So we can bring in third-party libraries, third-party models. Those can be deployed as well. Those can be managed as well. And this platform is open and extensive. So while we have all these components, you might have customers might have different ways to interact with it. They might have different pieces of the puzzle, so they can interact with the entire platform and still be able to use it. Any questions before I go forward?
No.
Okay. Cool. So I won't spend time on H2O and Driverless too much because a lot of folks know it, but just quickly highlight this and then jump to the newer stuff, all the new products we've added into the AI cloud, right? For the benefit of folks. So folks are not aware, H2O is our bread and butter. It's been, it's been being built for close to 8-9 years now. The H2O, the third generation, which has been around for many years, itself is very popular. So basically, it's a distributed open source machine learning library, right? It has support for all the common algorithms from, you can see a bunch of the supervised and unsupervised learning algorithms. It also has its own stacked ensemble in AutoML. And the great thing is you can use it to any environment you like. If you're an R user or a Python user or a Scala user, you can just connect to it directly from your environment. You don't need to learn a new IDE or new language. You can just use it from the environment you like. And the nice thing is under the hood, it takes care of all of the distribution of your data. So if you bring in a massive data set, it can run at scale, and you just throw more nodes at it, and it can take care of you for you. So very powerful, and we continue to add more algorithms. So this is continues to be a workhorse that powers a lot of large enterprises across the world. They continue to use this on a regular basis. Right. And then you have Driverless AI, which is our AutoML engine. This is brings in all the best practices we've learned over the years from the best feature engineering techniques that from our grandmasters. We learned all the different ways to tweak and find the best algorithms. And we have explanations for all the models that we built as well. This is also all built part of the platform and available through the platform, right? So this is your AI engine that is the workhorse for many users. So yeah, it's a no-code deep learning no-code interface to build models. And then the great thing is it allows you to do a lot of expert settings as well. So you can extend the platform as much as you want because there's notion of bring your own recipes. So you don't have to take what we give you out of the box. You can extend this. We have over 250 recipes that are available for different transformations, different algorithms, different scorers. You can use it to extend that platform. One of the things that we've added recently onto the Driverless platform is basically a really nice wizard that what that allows us to do is basically even a junior data scientist or a junior citizen data scientist can now build models in a step-by-step walkthrough way. So it's almost like TurboTax for AI, right? So it's a really simple way to start building models, and I'll time permitting, I can maybe show a quick demo of that as well. Then the next AI engine, this is something that we've introduced on the last year, is Hydrogen Torch. This is our no-code deep learning engine. And what this allows us to now do is, and for many years we've been focused on structured data, but a lot of our data, more than 80% of the data that's being created is unstructured, right? Images, audio, video, text, and very few people have the ability to tackle these hard problems, right? Because the unstructured data is notoriously hard, right? And using just off-the-shelf deep learning tools is not easy. How do you tune them? That's super hard. So what we've done is we've allowed now to bring in any of your text, image, video, or audio data and solve all those problems. And this is a list of kinds of use cases we can do. We can solve for all the, of course, your standard classification regression. We can also do stuff like object detection, semantic segmentation, metric learning on your image data. On the NLP side, we can do things like token classification, span prediction, sequence-to-sequence learning, of course, and metric learning. So you can do a lot more different type of problems on your data. And that is the great strength of Hydrogen Torch. It doesn't, you don't need to learn any framework. You don't need to learn coding of deep learning frameworks and start using it automatically. The nice thing is it comes with a bunch of pre-trained models out of the box. So even if you don't have a ton of data, you can start by using a pre-trained model and build off of it, right? But if, of course, if you bring your data, you can fit a good model on your own as well. And everything is nicely deployable, so you don't have to worry about how to deploy your artifact. It's integrated with an MLOps, so after you build a model, you have one-click deployment of your model as well. And gives you a nice set of tools to validate your model as well. So you don't just build, it's a nice wizard-like interface to build it, and then you can then see the results as well to validate it. The next engine that I want to talk about quickly is, so think about all the data that enterprise has, right? So you have your image, audio, video, text, tabular data, time series data. Another big source of unstructured data in an organization is often these documents. So, there could be forms, there could be receipts, invoices, bills, you name it, faxes, they're all sitting there, contracts, and often that data is not accessible because it's in the form of PDFs or scanned documents that you can't get data off of, right? So there's, of course, OCR tools that help you get to a certain extent, but they are notoriously finicky. They don't understand templates. If the documents come from different formats, they fail. So we think of that as another valuable source of data, and bringing that into your data ecosystem is key. So document is built to understand and process like massive amounts of unstructured data. So this is enterprise grade. We're talking about like hundreds of millions of documents, bringing them all in, bringing all the data, understanding the data, creating context around it, and creating essentially features out of your data. That's the goal of document AI, right? So we can, like I said, bring in all kinds of image, document, text data. We have a self-service labeling interface as well. So you can label the data yourself, annotate it, or you can use, if you have annotations elsewhere, you can bring them in directly to the platform. You can do things like document classification, page classification, and entity extraction. And then you put it into a workflow. You can then write a post-processing workflow that defines how the data is going to be stored. And the key thing is all of this can be done with the human in the loop. So obviously you can use the engine for doing it automatically, but likely your chances are you might want your human in the loop to correct and offer suggestions as well. So that becomes an important part. So this is your end-to-end workflow for document AI, and it's built to handle all of this. The nice advantage of our the way we built this and why we think we have an interesting take on this is most of the OCR engines out there, they're good at reading text. And there's a bunch of things they are good at, tools out there. They are good at reading text and understanding context from templates. Meaning, if you see a check always looks like the same format. So it's easy to find. They can have templates at circuit, right? This is what you use in your bank apps. Or if you look at, there's apps which can read your credit card. Again, they know exactly where to look for. Or if there's a W-2 they want to read, they know exactly what to look for. But the problem is when you have, let's say, a classic example is for hospital referrals. Referrals could come from different doctors, different hospital networks, different chains across the country, and each referral can look differently. So it's the same information, but there is no template, there is no format. You still need to be smart about it, intelligently find out the right information across all these different templates. And that's what document AI is good at, because it has a general purpose engine that can learn the information from across document formats. It can still read templates, but it doesn't need templates. It doesn't need the layout to understand it. So one of the use case we did, again, this is for UCSF, this is one of our early partners, is we were able to save like thousands of hours of time and thousands of hours of clinician times as well by taking all their fax documents and then reading it and understanding what must be done. This is all the referral documents. And they tried all kinds of LCR tools and RPA tools and didn't have much success. By applying H2O document AI, they were able to get phenomenal accuracy from the platform. So with that, I cover basically all the possible document types that an enterprise has. So an AI cloud needs to not just solve for one or two use cases, be able to solve for all possible. And then the final piece, next piece comes in is how do you then put it into a way? So you build these AI models, but how do people consume them? And for that, you have this AI app development framework called H2O. What it allows us to do is allow the same data scientists and the data analysts and the users who are building these great models, they're working with data, to very quickly build apps, dashboards for end users without having to wait for front-end developers or learning CSS, JavaScript, or HTML. They can, with a few lines of code, a low-code deep learning, low-code app development framework, build rich interactive applications. And that's the problem. That's what Wave solves for. You take Wave, data scientists can basically take their model or even take a notebook. We have one of these really amazing examples where you take a Jupyter notebook and create a dashboard out of it, or create like a nice website out of it. You can do that, right? So it creates a no-code or low-code app development framework, and I'll show a demo of that in a bit. Right? Next, I'm going to come to the operate part of the platform, which is the how do you then operationalize all the work you do. So let's say you build great models, great apps. What do you do with them? So first, you want to start with the feature store, right? So feature store is the bringing together the most valuable data of, in an organization, which is often hidden in silos, not intentionally because of existing. So these are often notebooks. Right? So data scientists have a great notebook with some sort of features. Sometimes these features are shared across in the form of they put it in Google Drive or OneDrive and share it, but there is no principled way to do that. And more importantly, a lot of these users are coming in with their own intelligence, and they need to know what kind of data is available in the organization. So the goal for the feature store is to provide this sort of like a water cooler for an organization, maximize your ROI, find the best features for your problem that could be built by someone else, get advantage of it, put it in production. Make sure that governance is a key part. Right? You don't just make sure that you want to see the right people can have access to the right data, permissioning is taken care of, but then we still have the ability to monitor what features went into a model, and then you can see those models if those features are allowed or not. Right? If you want to ensure that let's say sensitive features like demographic information or personal information are not, or PII is not included. So you can have, how do you ensure that data scientists accidentally don't shoot themselves in the foot? So having those governance capabilities becomes key. So feature store allows us to essentially bring in any of your data engineering pipelines as an organization, wherever they might be. If you have streaming problems or batch use cases, bring all your pipelines, and whether it's Databricks or Snowflake or Jupyter or in Salesforce, put them and use those pipelines to then, and you can write your own pipelines as well and create all the features and write it once. You write the features once and then store those features in the feature store. Feature store comes with an online and an offline engine that can have all the data, and it also has a metadata store that includes all the information. And then it can make that available for future training purposes, real-time inference purposes. It also provides you recommendations. It provides you alerts, drift monitoring. It gives you the ability to do, it automatically versions your data, versions your pipelines. So if you want to go back and do back testing or time travel on your data, you can do that as well. So all those things become available for your features out of the box. Right. So what the business then gets is scale. They can, safely store, confidently store terabytes of data, if not petabytes of data. They know that their real-time use cases can be handled. So if you need a model to be available in production for a low latency real-time use case, the feature store can just configure it for it. Feature store will make the data available with low latency. It ensures that your security is taken care of, all your data access and rules are honored, and sensitive data is masked, and sensitive data is encrypted automatically. So that allows you to then have a safe way to share even your sensitive data across the organization and get more collaboration.
Since you mentioned this, how is the masking and encryption automated, or is an option? Is it a checkbox? How does that actually happen?
It is a optional parameter. So when you bring in a data set, you can specify a data set as sensitive. You can say it's PI or SPI. The feature author can do it, and it becomes masked. We also have the ability to detect certain data types. So we haven't, so it's that we don't do it automatically, but we can tell you that, hey, this looks like a social security number, or this looks like a phone number, and we can tell you, and then you can then decide to mark it. So we have the ability to detect, but the feature author can specify it. Another thing you can do is if you have an admin, like a data steward in your organization, then you can have them review and put those rules as well. So and the good news is, once you, let's say, specify that this feature or this like a phone number is sensitive, it will be honored across the platform. So if I'm a new data scientist, I bring in a phone number field again, you don't need to specify each time. Already the system knows that, okay, phone number is sensitive, so mark it as sensitive. So it honors that for every future use case as well.
So in terms of masking, does a person need to tell this feature store to mask, or it kind of know what to do, or what is the process?
So first time when you upload or ingest a feature set, you register, and you can specify that these fields are sensitive, then they get masked. You have two options. You can say that I want this feature set itself to be sensitive, so only someone can access
Mm,
only with permissions. Or you can say that people can access it, but these two fields are masked. So I can access the data set, but the sensitive fields will be encrypted.
mhm. Okay. And how about encryption? Can you supply your a customized key or custom even external encryption system?
You can,
Yeah.
yeah. So we right now allow you to supply your own key. We do a standard
Yep.
SHA encryption,
Right.
and you can
Right.
use your own key for that.
Okay. Thank you.
Yep. Cool. Then coming to MLOps, again, I know some of you have been using your MLOps or played with it. Our goal with MLOps again is to ensure that we solve for deployment, monitoring, lifecycle management, governance, and these are often also the barriers to adoption at scale, right? Like deployment is hard. Different libraries, different toolkits, different data scientists have different ways of workflows. Bringing them all together is hard. Monitoring becomes hard as well, right? Depending on how you deploy it. If you deploy it as a REST endpoint, it's one thing, but if you deploy it as like a batch scorer or you deploy it on the edge, how do you monitor those models? Lifecycle management is key, ensuring that you have the right workflows, permissioning, who approved a model, who approves, how does a model go to production? How do you ensure that the accuracy is maintained? How do you ensure that you can then switch out a model without interrupting any downstream applications? Those are all become key ideas. And then finally, governance is important. ML and AI models need to be governed just like any other governance in your platform, right? Like just data, just like data governance. So having those best practices in the platform becomes critical, right? So AI clouds need to solve for that. So at high level, this is our MLOps sort of framework and vision. The goal is to ensure that we have an open deployment strategy. So we have all managements and registries, we have deployments and monitoring. And the nice thing is we have a lot of support. We can bring in data from different frameworks. Third-party models are supported as well in the platform. We allow for collaboration. Governance is built into the platform. And this can now be used by a whole bunch of different end user applications. So as our long-term vision, a lot of these things are being built today. But we have this really wide vision of bringing an end-to-end MLOps capability into the platform along with all the other pieces. Yeah. So like I said, want to make sure that we are open and interoperable. We can work with a broad set of tools. We have the widest range of deployment options, and we have governance for enterprise grade governance. So these are the big three goals that we set out, and this is where the platform is. So bringing all this together into Innovate, right? Like what does the end user get? End user gets, using all those pieces, we can build a bunch of applications. So the H2O App Store, we launched this over a year and a half ago, but we have over 100 applications in the App Store. So users can build applications, data scientists can publish their models. And great thing is other users in the organization can discover those. So let's say you build a great fraud model, you put it into an application. Let's say a business user can come in and find it, right? How do you ensure collaboration? And again, unlocking of insights into organization. That's why I built the App Store. We have a bunch of pre-built applications that we provide out of the box. A lot of these are demos, solution accelerators. These are good toolkits to start off with, and we built a bunch of these, right? Like for example, when we and COVID was still very prevalent for some of our hospital customers, we built these forecast apps. We built for some of our healthcare customers, we built county prediction app, bed predictions, how many patients are going to come, no-show predictions for appointments. We build a lot of these useful applications for them. We've done a lot of data science applications as well. And then, of course, for customer success, customer service use cases as well, like predicting churn, predicting who's going to, which customer is angry or pissed off, how did the call go? All those use cases have example applications over here. And it's all built to run on a flexible infrastructure. So just to cap it off, we built this on top of Kubernetes. So this entire stack can run on on-prem or on the cloud. We work with all the big public clouds, Azure, AWS, GCP. We also work with Red Hat and HP and VMware. We can pull in data from over 200 data sources. Or wherever your data is, it can work in your stack, pull in data, work on the platform. So with that, I'm gonna just hop this view and then go quickly to show the cloud itself. Let me know if you have any questions while I'm doing that as well.
Let's see some demo.
Yeah. All right. Okay. So this is the platform. When you come to the AI cloud, you will see a lot of things, and of course, it's a little busy, but let me walk through what you mean. What are the key things, right? So you have the key components. You have driverless AI, you have H2O.3, you have MLOps, hydrogen torch, and notebooks. So these are where data scientists will start. On a day-to-day basis, users can come in, either spin up a notebook and start working on it, or kick off driverless instance and start working on it. Go to hydrogen torch and build model. So whatever your tool of choice, you can start with that. We also have a lot of applications. Let me quickly show you what kind of applications you have. So if I go to the App Store, you have all these other applications that we talked about. And depending on what your organization, maybe you might have some smaller set of applications or whatever you build internally. And we'll come to some of these interesting applications down the line. But if you want to just go ahead and build a driverless model, you'd go and launch it, go to Steam, launch it just like you would do, right? Start an instance. I'm going to pick one that is already running over here. And then I come over here. So I have a low data set. So what I want to show is one of a new capability, which is basically this predict wizard. So this is the wizard I talked about. So in the past, you had to build a model, and it's still very easy to build a model. But now this wizard now allows you to do is, depending for, so let's say, junior data scientists or citizen data scientists, we can very easily, and even for experts, it allows you to walk through step by step, give you all the options, and walk you through what is useful. So let me just pick one option. Go ahead. So in this case, based on the data, what do you want to do, regression or classification, right? So if I have regression, all these choices. If I want to do classification, so I want to do classification. I want to predict default payment for next month, right? So I pick that, I continue, and it says, okay, we don't need to sample. The data set was large. It will suggest some sampling options for me. It looks at the data sets. Okay, this is the target distribution. Everything looks good. It walks me through step by step, right? If something is wrong, I can always go back and fix it. It detects ID columns. Okay, it says, do you drop the ID columns? Makes sense. I want to drop it, right? So I drop it. It says, do you want to check for other columns that you want to drop as well? So I'm going to check. I'm going to let the system check for it. It'll look for missing values. It'll look for nulls. It'll look for correlations and give me all that information. So right now it looks very quickly. It looks for all the bunch of correlations. Says, okay, these are the features that could be leaky. So right now none of them are very leaky. So if something is super highly leaky, it will tell me that, hey, maybe this feature should be dropped. So right now nothing is leaky. So it says, okay, you don't need to drop anything over here. Go ahead. So I'm gonna go ahead with this. And then it says, are you planning to deploy this, or you just want to do like quick analysis? Right? This is a key part, because this determines whether you build a model with a Mojo or build a model that has that needs deployment artifacts, right? So I can say, I'm not ready for production. I just want a fast model, right? I said, it saves time not doing stuff. I'm not going to do reproducibility. There's no time series because no date time column was detected. No image problem, no language problem, right? And none of those are good. Now I'm saying, okay, just use all my data set, right? There's no test data set, so I can just ask it to create a test data set. I said, okay, great, split my data. Then it looks good. And I can say all rows are independent, and then it'll go kick off a model. And while it does it, in the past, you might have seen the accuracy, interpretability, and time knobs. So instead of doing that, it gives you some options where you can say, hey, I can make a very quick model, or I need to win like a Kaggle competition. Go knock it off, right? So it can take as much time as needed, right? So I'm just gonna say, building a very quick model, or I can just say keep it simple, right? So just say keep it simple. I can also have the option to limit it to a specific wall clock time, right? I can generally reduce model complexity size. I can do all those options as well. So I hit it, and then it will go and ask me what kind of scorer. I'll just keep it AUC. And this is another nice thing. It goes and checks all these things. It makes sure that, it's like TurboTax. Make sure that you don't miss out on anything. And then it goes and builds the model.
Sorry.
Sorry. It goes in and they'll build the experiment. Right. So the kicks off experiment, I can come back and review it as well. Go back to my cloud. So that's driverless AI and some of the new capabilities in driverless AI. One other piece I want to show in driverless AI very quickly is, let's say an experiment is finished. You can also we can get all the deployment options. We have this really nice option to also go and create a recipe out of this. So this is nice because what you can do is you can get the final recipe that driverless AI built, and you can go and actually see that as well. So the entire code, the pipeline it generated is now available. So you can reproduce the exact single same model, the entire Python code for creating the automobile, like the specific model is now over here. And that's very valuable. So if you want to reproduce it or you want to change it, you want to say, okay, I like driverless AI, but I want to go and change it, you have the full option. This is the entire pipeline that got created. And you can go get the Python code, change it, put it into GitHub and automate it. You can do whatever you want, right? So this is a nice feature you have available, and then you can use it for new experiments as well. So if you want to recreate exactly the same experiment, this is what you would do. You just use it again. Okay. Let me go back to the platform. I want to show you very quickly what Hydrogen Torch does, right? So this is our, like I said, the no-code deep learning engine. Come in, I visit this. I'll just go hit demo mode on. So very easy. Just import a data set, create experiment, and expect deploy, right? So you can bring in data from different places. I can just start by importing from S3 or pulling it from a local. We already have some data sets over here, so I'm just going to look at some of the data sets. So we have a bunch of these common data problems that are loaded over here. Let's say pick a data set, right? I want to look at one of these image problems. Let's image object detection. Let's do a simple one, right? We can look at the data. This is the information in the data set. I can do a quick visualization of the sample data. So this has the, it's detecting wheat or not, what kind of data it is. There's some statistics over here. It gives me a summary, what type of data. And then I can create an experiment very easily with that, right? So I can pick up the data set, whatever data set I want, and then pick on it, and then start building models off of it, right? So you pick whether what I'm doing, regression or image classification, problem type, pick it, and based on that, you start proceeding ahead. You have the option to go from skilled. So let's say I'm a novice, I pick novice, then the software does a lot of the selections for me. It gives me only a few options, but it has good smart defaults or everything. Picks a nice backbone for me, and I can just start running experiments, right? But if I'm an expert, I can pick that and I get a lot more options. I can go and actually tweak the model. I can have ability to change the epochs, the gradient clips, accumulation, how do you want the model to be optimized, right? All of those options become available. So depending on the user's capabilities, you can get as as deep or as light as fewer options as you want. You can also specify how many GPUs you want. You can have mixed precision on or not, right? So it gives you a nice way to go from expert to novice, get all kinds of capabilities. In the interest of time, let's look at what you get. So assume I ran an experiment. So you have a bunch of these completed experiments over here. I can then go and see some of this, right? So this is let's say metric learning use case. So I can see what kind of data you have. It gives me the training rate, batch loss, all this information. I have some summaries, statistics as well, some metrics. This give me the validation score. But I want to actually see the use case, so that I can go and pick up and they can see what information it's providing, right? So in this case, it's finding whether it's a bike or not, right? It gives me all those insights. It gives me the best validation samples. So in this case, I can see which ones are the closest, right? These cycles are all close to each other. They are similar cycles. Great. Then it shows me the worst ones where it actually missed, that you couldn't find any matches, right? So it shows me that. Let me show another example. This one, right? So this one we are trying to read off of these images of coins, what the total amount is, right? So it's trying to read the coins and say what the total amount of the coins is. So you can see the best examples, right? So Vex examples is where it got the prediction correct, the label and it exactly knew what the coins were, it predicted it correctly. Then you can look at the worst ones. The worst ones are probably where the image was dark. So it couldn't even see what those coins were, it got it wrong. So it allows you a nice way to then go fix it, right? And then if you want to go fix it and add additional labels, we have a tool for that as well. So you can come in and we have a tool called Label Genie that allows you to now generate, build labels for your data, improve your models, right? So this is a really nice, quick labeling tool that we provide as well. So
It's Hydrogen Torch mostly for image,
image
models
and NLP as well.
and NLP also. Okay.
Yep. So
That includes like the tabular data or the test data.
sorry, what's the question? Can you repeat again?
Sorry, this is Ray from CBS. I mean, for that platform, does that include like any tabular data or the text data, or only
So,
for the image and
Hydrogen Torch
LLM?
is focused. Yeah, it's focused primarily on NLP, audio, and image.
Okay.
All unstructured data only. And then for tabular data, you use driverless AI.
Okay, I got you.
Yeah.
So when I need to pick driverless AI and hydrogen torch, if it's tabular data, it should be driverless AI.
Correct. Tabular data, IID time series, you pick driverless AI.
Okay.
And even if you have, let's say, a text column, but it's still tabular data, you still pick driverless AI. When you have completely unstructured data, you come into hydrogen.
Okay.
Right? You have pure chunks of text. I'll show you some of the NLP ones as well, right? Like so. This one is the text pattern prediction one example. Like here, you're basically asking questions and answers off of just text, right? So you have just pure unstructured data problems, right? These kind of examples, Hydrogen Torch is great. And if the great thing is it's a general purpose framework, so you can extend more problems as well. So we have a bunch of these, but if you have more problem types that you want to solve, let us know. We can add those as well. Okay. Yeah, just quickly show you Label Genie over here very quickly. So if I have data and then I want to do some annotation, I can do annotations over here. So if I don't have enough labels, I can start with annotations, right? So I want to, let's say, do Amazon review. I'm going to pick, in this case, entity recognition, right? So I want to say, okay, look at the comment. I want to find entities. So I'm going to say, look for phone. I can add an entity for vendor, for brand, something, right? So I just made up some entities and I can continue to annotate. And I can then start doing annotation over here, right? So it provides, in this case, the so there is no phone over here, but I could actually call this object, right? But if depending on what I pick, it will show me the right values as well, right? So in this case, I can see this is the vendor, so I'm going to call that the vendor, right? Go next and then find. So this is the vendor, so I can do that, right? So it allows me to annotate. Once I finish the annotation, I can export the results and then go back to Hydrogen Torch to start using it. So it allows me to complete the loop. Okay. Right. Then let me quickly show the other piece, which I think folks are interested in, which is feature store. We only got like 8 minutes go. Probably won't be able to get to document AI, but I'll show the feature store real quick. Any questions while I'm bringing that up?
Yeah, I do have a question. Sorry for I missed the half of your talk.
No
Yeah, my question is for that one is for the torch, it includes the training, inference, and the data processing, right?
Right. So it does some amount of data processing and some amount of data augmentation in the platform itself. So when you create an experiment, you can specify some of those pieces, but it'll do a lot of this. It has grid search as well, and it'll do it. It'll do it all for you. Just bring in the data and bring in your annotations. And if you don't have annotations, use the label Genie to create annotations.
And also, we can also create our customized model, right?
You can customize your model as well. So in this case, if you go in, you can pick your own backbone as well. So we provide some backbones, but you can start with your own backbone.
Okay. Like we can code our customer model and import into the touch, right?
Correct. You can import your own base model, and you can work off of that.
Okay, yeah, thanks.
Yeah, so this is the feature store. Very quickly, like I said, it's a way for us to go through all your data sets or feature sets in your organization and look at that. So you have permissioning and sharing over here. These are, let's say, if it's a feature set that you need access to, you request access and specify and then the feature author will get access to it. So I can say I need it need for exploration, and select consumer access and then request. The request will go in, and then I can go and check status to see if my feature store request got approved or not. So in this case, it is pending, right?
Mhm.
You can create a code snippet. You can generate basically a PySpark code or Python's code. So once you come to the feature set itself, you'll see all the information, metadata about who created the feature, when was it created. It'll tell you whether, in this case, there's no sensitive data. If there are sensitive data, those will be marked as well, and they'll be masked over here as well. But since there is no sensitive data, I can actually go and look at the features themselves. I'll get some summary statistics, some information about the feature. I can go review it. And I can see whether there is time travel enabled. In this case, there is a time travel enabled as well, right? I can see how long the feature is available. And if I want to use it in, let's say, Python, it can generate a code snippet for me. So I can use a code snippet directly, connect to my Python client and start using it. That's how easy it is, right? If I want to create a new feature set, I can do that as well. It's all of these things I'm showing. It's easy to do from the Python API, and that's how most users will use it. But if you want to create it, I can specify what project a feature belongs to, select an existing project if I want to, or start a new project. I can specify whether this is a raw or engineered feature, specify whether what status it is in, put additional tag information, and then I would specify the list of features like the schema, and then the primary keys, and then streaming connection, and that's it. This is what I would do to create the feature set. And it's super easy to do this all in like one command from Python, right? And once it's there, I can come in and search. As a user, you can come in, you can look through projects, look through feature sets, data sources. You can ask for features. You can look for date ranges as well. And it says a really smart search to find the best features for you. And when you create a feature, you can also specify that feature to be available for online. So for example, if in this case, it's not, if I turn a flag on that this feature needs to be available online, then it'll be available in the online store as well for real-time access. Okay, I know we only have 4 minutes left, so I want to read some time for questions. So we rushed through a bunch of things.
Do you have any questions? Yeah, I think, maybe my last question is for the feature store. Is it like the hierarchy text? Like the first hierarchy is feature store, and the second one is feature sets, right?
Correct. So projects, feature sets, features. That's the hierarchy.
Okay, I got you.
So think of project as basically like a folder. So it's a folder. It's just a folder. In the project, you can have many feature sets, and each feature can have many features.
Okay. And main usage for the feature store is still the online prediction and the batch prediction. Is that correct?
And yeah, and of course for training as well. So other big use cases that you reuse the features, right? So you created some amazing features. Someone else in the organization can also access that. Because once it's in there, feature store will keep maintaining it. It'll keep the versions. All you do is register the pipeline, tell it that how frequently you want to update the features, and you set it up once and forget about it, right? It'll keep updated, make sure it's maintained.
And if someone create a feature store or feature set, and if the other one need to get the data from the feature from the feature set, he need send a request, right?
That's correct.
And
you can keep it open too. You can say certain feature sets are fully open. You can say that they don't need access. If it's like, hey, it's a public data set, or maybe it's a data set that's openly available, so you can make it fully open. So then you don't need access. But by default, you need access. You need to request.
It is any of this service run on GPU?
Feature store doesn't need GPUs.
No, I know, but all the service you have covered, like Hydrogen Torch.
Hydrogen Torch, yes, runs on GPUs. Document AI runs on GPUs. Driverless AI runs on GPUs.
Yeah.
So they can run on CPUs or GPUs. Obviously, Hydrogen and Document AI benefit tremendously from GPUs.
Will be faster in GPU, right?
Correct.
Okay.
Yeah.
Same thing for MLOps. We didn't cover that. Even in MLOps, you can deploy models. You can specify if it's an image model, NLP model, that you want to run the inference on GPUs as well. We can support that too.
I think some of the new stuff we should deep dive, but yeah, give it another day. Right?
Yes.
Thank you, Milot.
Thank you all.
Thank you.
I learned something new.
What's that?
I learned something new.
Yeah. No, hopefully that was the goal, right? So hopefully,
Yeah.